Hello, hello, hello. Good morning, good evening, wherever you are. My name is Mark Borstein. I am the CTO of Tremolo Security, and this is our last lab for Chapter 9, Kubernetes Enterprise Guide, Chapter 9, Building Multi-Tenant Clusters with vCluster. So we're going to be having some fun today. We're going to be pulling together a lot of the things that we've learned, not only in this chapter, but in past chapters. Now, Scott Surovich, my co-author and partner in crime, could not join us, unfortunately, or he might end up joining us late. We'll see. Unfortunately, sometimes the day job gets involved. Yeah, so in the last couple of chapters or labs, rather, what we've been doing is don't need to worry about that. Joys of live streaming, right? What we have been doing is focusing on building up a vCluster, a virtual cluster, individually, right? We run the vCluster command to create it. And even before that, let's talk a little bit. Virtual cluster is a project from Loft Labs that allows you to run a little Kubernetes cluster, a little tiny one, inside of your host cluster. And the value here is that your workloads, when they talk to the API server, they're not talking to the host cluster API server. They're talking to their own API server, their own single API server. So what that then gives them the ability to do is say, all right, we're going to have our own CRDs. So that way, if you've got different systems, different workloads using different types of CRDs or different versions of the same CRD, you're covered. It gives you the ability to isolate RBAC. And so let's say you've got a system that needs a lot of different namespaces, but only gets one namespace in the host cluster. Well, now you can carve that namespace up a lot of different ways. So it gives you a lot of capabilities. Kind of the trick with it though is it's still a cluster. Still got data. You still got to manage it. You still got to maintain it. And so in the first couple of weeks in our labs, we focused on building out those vClusters kind of manually, the same way you might build a host cluster. And but this is Kubernetes, and you know we want to automate. So we're going to go ahead and we're going to do this in a way that lets us automate things. So in this final chapter, we're going to build out a self-service portal. We're going to be integrating a lot of the stuff we learned in the last couple of chapters, as well as what we've learned earlier in this chapter. So let's think about this for a second. We've got we're going to hand out these vClusters. The first thing we want to do is we want to automate how that gets generated, right? You don't want to be doing that manually. That's one. Two, in the beginning of the chapter, we talked to, in our first lab, we talked about how a vCluster is still a cluster. You still need to provide enterprise authentication. And so we want to automate that onboarding process, right? Like we showed how to manually do it a couple of weeks ago, but this time we're going to automate the whole thing. So that's two. Three, secrets management, right? We spent an entire chapter on how do you automate secrets management. Well, just because the virtual cluster doesn't mean we don't want to do secrets anymore, right? We still want to manage our secrets properly because these are enterprise clusters, and we're focusing here not so much on the use case of getting a quick test cluster or a development cluster. We're talking about a cluster that is meant for production workloads. And then finally, we're going to want to make it so that it's easy for users to get access to it using our enterprise authorization. So we're going to want to tie everything into Active Directory. So if we come to right now, I am in chapter 9. I'm going to come over here to page 290. I'm actually going to share screenshot or share the PDF of the book over here. Oops, make this a little bit bigger. So let's look about our multi-tenant platform. So the trick when you're dealing with any kind of integration, and that's really what this is. It's an integration, right? Because Kubernetes doesn't know how to do users, right? We covered that in chapter 6. Kubernetes doesn't know how to do automation, right? You need engine or something to do the automation. Um, Kubernetes doesn't know how to do secrets management. Like it does secrets, but it doesn't know how to do management. Uh, and so we're going to go ahead and use all these different things that we've learned about and bring it together. So portal authentication, we're going to use OpenUSN and Active Directory. That's what I've been using the whole time. So we'll keep doing that. A tenant will be a virtual cluster. So every single name, instead of namespace as a service, we're going to use a vCluster as a service. So that'll make it nice and easy for users to get access to their clusters. We're going to use authorization off of Active Directory groups. So we haven't done this yet in the book. Well, actually, I guess we did. We did it in chapter 6, so I lied. And so what we're going to do is we're going to say, look, our enterprises are responsible for authorizations, for managing who has access to what. So we are going to assume our Active Directory has groups in it for the various roles inside of our vCluster, and we'll map it in. Where things are getting a little tricky, and we'll look at the architecture here in a moment, is we're going to need certificate management. And the reason for that is in last week's labs, we used MySQL as the backend database for K3's deployment. And the nice thing about that is that you can use certificate authentication when authenticating to MySQL. So that means we need something to generate those certificates. So we're going to use Cert Manager for that. For secrets management, we're going to have Vault running in our host cluster. And that Vault is going to integrate with each individual vCluster as its own cluster. So the virtual clusters will be treated as individual clusters. And finally, we're going to use OpenUnison's built-in orchestration workflows. So far in the book, we've been focusing on OpenUnison as an authentication tool. This round, we're going to use it as our onboarding tool. So let's take a real quick look at what everything looks like underneath the scene. Because the thing is that a lot's going to happen, and it's all going to be under the covers. And it's all just going to, like, in theory, magically work. But there's a lot of orchestration going on. And so what we want to do is we didn't want to get bogged down in the particulars of this implementation so much as we wanted you to understand what all the different touch points are and how you could implement this on your own if you wanted to. So here's our host cluster and our virtual cluster. So Ingress is going to be hosted on our host cluster with Nginx. So nothing different there really from previous chapters. And then there's going to be a namespace, and that tenant namespace is going to host a virtual cluster with its own API server. That vCluster is also going to host its own OpenUnison. And the reason for that is we want these vClusters to be standalone. And so this way, the vCluster will integrate with the control plane OpenUnison, but won't have the secret over to Active Directory, in this case, service account, username, and password. So that means that anything that we run in this tenant can hook up with Active Directory without having to know that username and password. So now that allows us as an SRE team, as a central management team, to delegate a capability down to the vClusters without having to give them the same permissions that we have. So it gives you a more secure way to enable SSO. So imagine that a team running Grafana on one of their vClusters wants to integrate SSO. They would integrate it with their OpenUnison, not with the control plane OpenUnison. So it gives you a separation. We're going to use Cert Manager here to do certificates, right? Makes sense. We're going to have MySQL for centralizing K3's databases. And then finally, we'll have Vault. So when we go to onboard a virtual cluster, step 1 is going to be to create the tenant. Step 2 is going to be to issue certificates for the connection for MySQL. Step 3, we're going to provision a database into MySQL for Kine, which is the back-end system that K3s uses to allow databases. Step 4, we're going to actually provision our vCluster. Step 5, integrate Open Unison. And finally, step 6, we're going to integrate Vault. So there's going to be a lot going on under the covers. So now that we know what we're going to do, let's do it to it, right? So I've already got control get nodes, kube control get pods. I'm not sharing my screen, so you're not going to see much. Oh, I wasn't sharing my screen during that entire conversation, was I? Blimey. All right. I'm going to add the screen to the stage. So let's go ahead and share this picture again and go through this again one more time real quick. See, this is what happens when I don't have Scott on the screen to tell me, hey, Mark, you're not sharing anything. Okay, so let's try this again once more with feeling. Why doesn't it see? Why don't you see that? Something's wrong. Hold on. Remove. Stop screen. Present. Share screen. I want to share the entire screen. Oh, I think I was sharing a window. Okay, there we go. All right. Now we're cooking. Okay, so let's try this again. I'm going to hide this because you don't need to see that. All right, so step 1, we're going to provision the tenant namespace. Step 2, we're going to provision the certificate that's going to handle authentication between MySQL and our kind cluster that runs kind as a backend. Step 3, we're going to provision the database. Step 4, provision the vCluster. Step 5, integrate Open Unison said vCluster. And then step 6, provision into Vault. All right, so now that we've done that and I have actually showed you the picture, live TV, folks, right? Let's go ahead and do it. So I am on page 292. So 292 starts with clearing everything out. I've already done that. So kube control get nodes, right? Kube control get pods, all, right? Okay. And if you've been watching the labs the last few weeks, you've noticed me complaining that for some reason my VM is running slow. I figured it out. So my lab, I have network attached storage. Excuse me, that's on 2.5 gigabit. And the problem was that particular VM, this VM that I used to run everything, was attached to that instead of my local thin storage. And so that was really slowing everything down. So that once I figured that part out, we were in good shape. So, all right. So I've already created my cluster. So I'm going to go into the multi-tenant chapter. Chapter 9, multi-tenant setup. And I'm going to deploy Open Unison. So this one's going to take a minute. And we are doing a bunch of stuff here. So the first thing we did was we deployed Cert Manager. So this can take a moment. And the great thing about Cert Manager is that it automates everything, right? So we're going to be able to automatically deploy without having to issue certificates. And the great thing about doing certificate authentication MySQL is this means that there is no tokens that's static anywhere, right? Like it'd be great if we could use a pod to authenticate to MySQL, but that's a bridge too far probably. So we've got Cert Manager deploy. We have, oh gosh, we're just churning right through this. So we've got Cert Manager deployed. We've got MySQL deployed. We deployed the dashboard. Now we're deploying our Active Directory, right? Like it's not really Active Directory, it's Apache Directory, but it gives us the same look and feel as an Active Directory. So this one takes the longest because it's just a really big image. And then once we have that done, we'll go ahead and roll out Open Unison and then Vault. So we got a lot going on here. We'll take a look at what those different pieces are once they're rolled out. Doo-doo-doo. And if you're out there, if you are watching, please feel free to say hello. We love talking to folks. We love answering questions. So we're right now rolling out Open Unison. Operators deployed. And I'm just gonna go double check, make sure everything's copacetic here. Now this one takes a lot longer. There we go. All right, so ActiveMQ is running. Control. There we go. Okay, so everything's going well. Hey, Shabir made it. Shabir, I'm saying that correctly, right? Shabir? But thank you for coming to say hello. All right. So this takes a little bit longer than past Open Unison deployments that you've seen because we're not just deploying Open Unison, we're deploying Open Unison. We're deploying ActiveMQ for messages. No, Shabir, happy to repeat so far. Really, all we've done is we are deploying our underlying infrastructure. So we've deployed the deploy Open Unison script in Chapter 9 multi-tenant setup, which includes so far Cert Manager. Then we did Cert Manager. Then we did MySQL Kubernetes dashboard. We just deployed Open Unison, and what you see on the screen is deploying Vault. So everything is now up and running, or at least it will be in a moment. We're going to go ahead and wait here about 30 more seconds until Vault is finished rolling out. And cool. All right. So let's tie this back to what we've rolled out. So so far, I'll bring this back. I'm gonna bring back our picture. All right. So what we've rolled out so far in this script, we rolled out our control plane Open Unison. We've rolled out MySQL. We've rolled out Cert Manager, and we've rolled out Vault. And that is all accessible from our local system. So like if I go ahead and where are we here? If I do ktou.apps, it's actually 53. I upgraded my Mac last night, so I'm going to get a lot of those errors. I'm going to log in, same username and password we've been using in the past. M Mosley start 123 super secret. So good question, Shamir. Or Shabir, I'm sorry. Do you guys prefer Vault Secrets Operator over ESO? So in this lab, we're going to use the Vault Secrets integration directly. When we get to chapter 19, which is the last chapter where we do our big final platform, we're going to use external secrets operator. I personally prefer external secrets operator. I think, and going back to chapter 9 when we talked about this, I just personally like vaults or Kubernetes secrets. It's a standard API. It's the only standard API for secrets. Like there is no standard API for secrets across secret managers. So it gives us as applications running on Kubernetes consistency. And then also it gives us a little bit of flexibility. I don't see you actually getting that much better security out of the direct integration with the secret managers. But yeah, so that's where that is. So we have Open Unison, and if we go and we look at our, it looks a little bit different than if you saw the video for Chapter 6 or even earlier in Chapter 9, where it was just we had the control plane, we got our dashboard running, everything looks good there. I'll make it easier. And when we go to home, when we go to request a new namespace, this is where we're going to be in a minute. So this is where we're going to request our new vCluster. And then I'm going to go ahead and show off Vault here a bit. So Vault dot apps dot 192.168.253.ip.io, right? Yeah. So should be pointing out here is restart deployments on secret updates. So yes, that's a good point. However, ESO will update secrets. So if you know how to look for changes in secrets, granted that requires a little bit more intelligence in your application, but good point. All right, so I'm going to grab the token. Now, whenever you run anything with Vault in our labs, we put all of the tokens in the home directory with unseal. Anybody who's screaming at me, we see your token, this is going to be gone in the next couple of minutes, so don't worry about it too badly. But in Chapter 19, when we do the big platform, we're actually going to integrate Vault with Open Unison. So it's all SSO enabled, so that goes away. So right now we have our integration with Kubernetes, and we are set up the same way we were in Chapter 9, Chapter 8. Yeah, that was last chapter. Last chapter when we did Vault, where Kubernetes is going to validate tokens, service account tokens, at the subject access request level, rather than just at the JWT level. That'll give us a little bit of additional security. So far, we have deployed all of our underlying infrastructure, and now we can go ahead and onboard a tenant. Whoops, I just hit the wrong button. What did I do? Escape. I don't want to be in full screen mode. There we go. So we can go ahead and start onboarding a tenant. So where am I? I am over here. So we've deployed everything, and I am on page 293. So we're going to create a new namespace. We're going to deploy to our control plane cluster. Our namespace name is going to be tenant 1. Now, it is super important for this lab that you spell everything and do everything exactly as you see it in the book. And that is because we make a bunch of assumptions based on names for the lab. That doesn't mean you can't name your tenants whatever you want. Do whatever you want, name it however you want. In this instance, it just becomes really important to spell it right, because I can say from firsthand, the labs go nutty when you don't spell it right, because I can't type to save my life. So let's go ahead and choose our groups. So these groups are coming right out of our Active Directory. And we've got one group defined for admins and one group defined for viewers. And we're going to call it Chapter 9 Demo. So this should line up with graphic 9.8, right? Tenant 1, tenant 1. Yep, that looks good. So we're going to go ahead and save that. And I'm going to close that. So not everybody in your enterprise should be allowed to just go and create a vCluster, right? That could cause problems. So the workflow actually opens up an approval. I just hit the refresh button now to try and keep the bouncing around, between screens and users down to a minimum. We're doing this all with one user. So our requester is also our approver, is our admin who's an approver. So I'm going to act on the request. And I'm going to give a justification. I've got a screenshot here for the chapter. So I'm going to approve this request. And this is when the fun begins. So I'm actually going to come over here. I'm going to go to the Open Unison namespace, find pods. I'm going to make this a little bit bigger so it's easier to see. So I'm going to hit the approve button. And what we're going to see here is a new pod get launched in a moment. Let's see, so we created the tenant one namespace, and we can see that's provisioning. It's already starting to provision. So if I come, our vCluster, so if I go to Open Unison, and then here's our onboarding job. Hey, Marino. Howdy, buddy. Welcome to the fun. So we're rolling out our vCluster. Is this auto refresh? There we go. And so Marino, you're coming in from LinkedIn, and I can actually see you, because I'll be honest, the LinkedIn integration hasn't been stellar lately. Go ahead and refresh this. Is that still going? So that's still waiting. So the way that this is going to roll out is, first we're going to roll out the vCluster. Then we're going to roll out Open Unison. Then we're going to go ahead and do the integration fault. So let's see, is this still churning away? Do I have this on auto refresh? I have to say, since the version 7 update, here we go. Okay, so the deployment's been created. So now if we go to tenant 1, we'll see that we have running virtual clusters. Now we can already see that we're launching we're launching Open Unison. So if we come back to the Open Unison namespace and we go to pods, we go to onboard vCluster. And let's take a look at the logs. Nope, wrong one. Sorry. Here we go. Onboard vCluster Helm, or Open Unison. So what's going on here now? This is actually a known issue that's been happening lately that we're going to address in the next version of Open Unison. Are we seeing? Yes. So Kubernetes has been enforcing much stricter rate limiting, and for some reason having the 2 Open Unison pods is triggering that rate limiting, and we need to do a better job of handling that, but not a big deal. Go ahead and see that as that gets terminated, we got a new one running. So okay, we're good there. That's a different error. That's an error. That's good. So if we come here to the onboard, and we can see we've got one running that's ready. So we'll just want to give this a moment. It should be auto refreshing. Okay, it is auto refreshing. So Orchestra is now running. And yes, also yay vCluster. And we are going to go ahead and deploy the Orchestra login portal. We're waiting for the HTML pod that holds our React app to run. So Open Unison's now been deployed into our virtual tenant. So if we go take a look at our tenant 1, we'll see we've got a few different pods here. So these are all our vCluster pods. Yep, all of what you were watching was us deploying Open Unison and the Kubernetes dashboard into our vCluster. Now I'm messing with it at the host level, at the host pod level or host cluster level, because I can. And yeah. So Marino brings up vNode. Not sure yet. I haven't had a chance to play with it. So what vNode is this was announced by Loft at KubeCon EU a few weeks ago. And this gives you the ability to isolate workloads on the nodes. Because, vCluster gives you isolation at the API server layer. It does not give you isolation at the node layer. Like your nodes, your workloads, we talked about how the workloads still run in the host cluster, where vNode will give you the ability to run that in an isolated way. So it gives you even more isolation, making multi-tenancy even easier. Obviously, it's not in the book, so we don't have that in the labs, but it's definitely something I'm interested in playing around with. All right. So we should be all done. And I'm going to go ahead and log out as M. Mosley. I'm going to log back in. That way I got my updated permissions. And so now we've got this tenant 1 here. So we've got our virtual cluster. It's accessible. I can go into the dashboard. And now I'm in, and you can see it up here. In the title bar, it says you're in tenant 1. And this, it's a cluster, right? We've got our Vault, sidecar integration. This is not the operator. This is the sidecar integrator. Yeah, so this is now a enterprise Kubernetes cluster, right? We've got our enterprise authentication. Show you there's nothing up my sleeves. I want to grab a token. Go ahead and let's create a new tab. Make it big enough so that it's reasonable for people to see. No, what did I do? Oh, come on. There we go, Apple. All right, so export kubeconfig gets make temp, get nodes, nothing there, right? We're going to paste it in, get nodes. We now have access to our virtual cluster. Now I'm going to actually show something really cool right now. Get nodes, clear. Okay, so I don't have access to that cluster anymore. We're going to be launching this pretty shortly. Hopefully in the next couple of weeks. We're looking for beta testers, but this is our new plugin, and so our new authentication plugin. This should just work. Probably should have tested this ahead of time to make sure. But hey, Kafka! Bonjour, my friend. So this is the new login plugin that similar to if you've ever used the kubecontrol OIDC login plugin, pops open a browser. You don't see this up here. I'm gonna this is the browser window that just popped open. You'll log in. This should work. It says close this window. Stupid LastPass. It won't let me close it because of JavaScript security. Kube control, get nodes. Sweet. So I can also use that plugin. That worked perfectly. I'm now able to access my virtual cluster as if it were any other Kubernetes cluster. So I'm not distributing vCluster to users. I'm not worried about port forwarding. I'm not worried about any of those things. It's just a Kubernetes cluster to me. So far we've gotten to the point that has been pretty similar to uh, where we've been in the past. It's just been automated, right? Like at no point did I run a vCluster command to create a new virtual cluster. Everything was automated. Tenants were able to onboard themselves. And there's, of course, a paper trail through our approvals process. Next, we're going to look at the secrets integration, right? Because this is an enterprise cluster. And so far in our book, we have done authentication using Active Directory. We've done authorization using RBAC. We've done vCluster automation, but we haven't covered the secrets aspect. So let's go ahead and see how secrets get integrated. So over here, I am on in the book. I am on page 296. So I'm going to come back to my, oops, that's the shared screen. So I'm going to come back here. And I'm going to, where am I? I need to go into the Vault directory. And I am going to set up my Vault CLI for the first time, for the last time. I can't type to save my life, though. All right, so now I have the Vault command created. And so now I can go ahead and do things via Vault. Now I'm going to come back to Vault here. Go secrets. Now there are no secrets, right? So let's go ahead and create a secret. Oops. Copy and paste this from the book. And then I'm actually going to come over here. You can see I started to do this. Let me make this bigger. All right. So some password, right? That looks good. I'm going to go ahead and run this command. The data was written. Now if I come back here, actually go back to secret. So now we have data in here. And we've got a specific folder structure inside of Vault. And what's significant about this folder structure, it lets us break up the virtual clusters in a way that allows us to have consistent policy. So we created several things in our workflow. And we'll go ahead and look at that in a minute. But you can see here, each vCluster is tied to the name of the namespace. But then inside of each vCluster, we then have namespaces. So we've got the default where we're going to deploy a pod here in a moment. And there is our some password. So yeah, if we take a look at this, it's a very secret password. Don't tell anybody. I'm looking at you, Marino. I you know, a little shifty. So we've got our super secret password. And how does Kubernetes, like how's the vCluster find it? So we go over to access. You'll see that we now have two Kubernetes authentication methods. One, that's our default, right? That's our host cluster. But then we have specifically one for vCluster tenant 1. And that is what gives us, he knows I'm not wrong, right? Like he's laughing it up, but it's a nervous laugh. So we've got our cluster read policy here. And this is what tells Vault, hey, when you get a token from this virtual cluster, go ahead and check the vCluster to make sure that the pod that you're getting it from and the token, it's all still valid, right? That's what lets us do that. Now, this gives us a little bit of a conundrum, right, in the enterprise world, because usually the people who run Vault are not the same people who run Kubernetes in an enterprise world, because Vault's used by a lot of things. It's not just used by Kubernetes. So now the question becomes, how do you automate this? Now, we do it in the code by calling the Vault APIs, but that means you have to have some pretty privileged access to Vault in order to do that. So, it's one of those things that sounds great in a book. How well, you're able to convince folks in your enterprise to say, hey, give my Kubernetes cluster admin access to be able to provision this stuff directly into Vault. Um, you know, I wish you the best of luck. I really do. But that's a whole other conversation. So we are making a few assumptions here. The other thing that we had to provision is a policy. So this is the policy for our host cluster. Here's the policy for our tenant. And so what's important here is you can see that anything authenticating with this has read-only access. Inside of the tenant one, we're getting our namespace directly from the service account. So what this means is any service account from a given namespace can read secrets associated with that namespace. Now, what if you said, well, I want to make sure only certain secrets can be read from certain secret accounts, service accounts? You could do something more specific if you wanted to. I would not personally recommend it. And the reason why I say that is the security boundary inside of Kubernetes is your namespace. So unless you've got something that is like an admission controller, like maybe you're using Caverna or Gatekeeper or something to limit which service accounts can be assigned to which pods. In all honesty, if you're at that level, what you need to do is separate by namespace, which brings us back to vCluster. That's why you have a vCluster, right? So you can go ahead and say, I'm going to, instead of trying to do everything inside of my little cute little namespace, I'm going to do it like I would in as a tenant in my own vCluster, in my own cluster, without actually having to have my own cluster. Right. So it comes back full circle. Now you can say, okay, well, my security boundary is the namespace in my vCluster. If something needs to be limited, I'm going to give it its own namespace and know that Vault is going to honor that separation. That gives us a lot of power. So we've got our secret created. We've got our secret creator. We've got our vCluster deployed and integrated. Let's go ahead and see what that pod looks like. So I'm going to come back here. So I'm still in tenant one. So I'm going to go over to the default namespace. We don't have anything running yet. And let's come back. I'm still here. Yes, I am. So I've put the password in. Now, what I'm going to go ahead and do is I'm going to create a new kube control config, right? Kube control get nodes. Nothing up my sleeve, so clear that up. And then I'm going to go into my portal and I'm going to grab a token from my tenant, right? That's tenant one. Grab my kube control command. Kube control get nodes. All right, so I'm inside my vCluster, right? Kube control. Well, my name is Mark and I don't know how to type. There we go. All right, so we've got our kube control going, or we've got kube control access. So we're going to go into, where am I? So here's our example. So we're going to go ahead and let's look at our pod. So we're going to create a pod that's going to run inside of our virtual cluster that is going to load a secret from that's going to load a secret from Vault. Okay, so here are annotations, and we run a script to do this to make it a little bit easier, but you can always update yourself. So this is where Vault is. You're going to authenticate using this authentication mechanism inside of Vault. We're going to inject everything, extra logging, just because this isn't production. It's a book. We want you to be able to figure out what's going on when it's broken. We're going to skip TLS for now. And then this is really where the rubber hits the road. So we're going to look up the secret by this path. Now, I will tell you, I never get more confused than trying to get the right path for things in Vault. I don't know why, but for some reason I can never get it right. And then finally, we're going to construct a environment variable file based on that data. And so there's a lot of things that you can do here, Vault, to construct some pretty complex stuff. So we're just going to keep it simple. And what our pod does is, this is really stupid simple. We're just going to echo that file, right? We don't really care what's in it. Well, we do care what's in it, but we're not doing anything really super cool with this. So let's go ahead and run this. Create Vault. Nope. Stop. Create Vault, right? So now let's go ahead and see what's going on in our, so we've got the pod created. Everything looks to be running well. Everything pulled. I don't see any errors. So let's take a look at the logs. And there we go. See? Look at that. So we've now gone and deployed a pod into our virtual cluster, right? That is talking to Vault using its service account. Now, if you remember back to the last lab, we talked about, well, it's really super important that you're, to recognize the fact that these tokens have 10-year lifespans, right? Well, that's why we wanted Vault to authenticate to to Kubernetes using subject access reviews instead of just using JWTs, because that's one of the classic examples, is authenticate to Vault using JWT, because those tokens are so long-lived. This setup, this pod dies, its service account is no longer valid, and Vault's going to not recognize it anymore. So that gives you that enterprise level of security. That gives you that check on a potential vulnerability. So yeah, we've done a lot in 3 weeks, if you think about it. And especially in this chapter, think about it, we bring the picture back up. I think this is the end for the lab, right? I'm not doing anything crazy here. Yeah, that brings us to the summary. So let's bring us all the way back here to this picture. And things went really smoothly. So might even be able to. I don't have my buddy here, Scott, to have some banter with. So we might actually wrap things up a couple minutes early. But look at all the stuff we deployed, right? We managed to deploy our cert manager, our control plane OpenUSN, our MySQL, our Vault. Everything gets integrated. And we were able to onboard a vCluster without any kind of manual, like, here's a vCluster command, right? So, yeah. So that wraps up chapter 9. We will come back to vCluster in chapter 19 when we build our platform, when we build our the big finale, the big book finale, the grand finale of the book. I don't even know what's next. What is chapter 10? I think chapter 10 might be OPA. Let's see here. Chapter 10. No, dashboard. We get to talk about dashboards next week. This will actually be a fairly quick I actually don't know. Do I have any labs in this one? Just scanning through this because we might end up skipping this one. So we used to have labs in here. Yeah, we don't have any labs in here, so we'll probably end up skipping the dashboard, to be honest. We used to have labs, and the reason why we don't have labs in this chapter anymore is the uh, the dashboard project eliminated the major anti-pattern that they had around authentication and allowing you to bypass it, and using a service account token. So once they did that, that eliminated a big lab. So we're actually going to skip chapter 10. We're going to go straight to chapter 11 for labs. And yep, OPA. So yeah, next week we'll be doing OPA. Oh, Shabir's got a question. What do we got here? Oh, any anti-patterns when using vClusters if you have too many controllers, operators in each vCluster? I mean, I wouldn't consider that so much an anti-pattern as a cost of doing business, right? Like having the duplication is unfortunately part of the trade-off between freedom and centralization. With this particular architecture, the thing I like about it is that the setup is much more centralized in the database management. So like the major, so to answer the first part of your question, the major anti-pattern I see with vClusters is they're not treated like Kubernetes clusters, right? Like if unless it is a temporary cluster, it's ephemeral, you're deploying it for like a quick development cluster that you're running locally, it should be treated like a Kubernetes cluster. If you're using vCluster Connect to talk to your cluster, your virtual cluster, you're doing it wrong. And that's an anti-pattern. That's a security anti-pattern. It's a usage anti-pattern. You're doing it the wrong way. So vClusters need to be treated as regular clusters. Then the question becomes, how do you manage it? And then from a management perspective, you've got kind of two approaches. You can use a, and we're not going to include the development version where it just has a local SQLite because that's not meant for production. You can either use a centralized database or you can use a etcd. The big question that I like using a MySQL database with Kind, if I can roll out the database, because I can do what I did here, where I can automate the heck out of everything. A lot of enterprises, you can't do that because somebody else owns the databases. You're not allowed to just deploy a database all willy-nilly. And so what you would then need to do is investigate. Now, we're using all the open source vCluster. vCluster Pro has a lot of additional features, one of which is like being able to have etcd inside of your control plane pod. Now then you're still managing an etcd, so that's something to think about. But if you don't control your own database, that might be where you get the most bang for your buck. But really the biggest anti-pattern I see with vClusters is people don't treat them as standalone Kubernetes clusters. They think they're something else, and they're not. They are a standalone Kubernetes cluster. They're just running inside, you just see behind the curtain, right? Nobody runs, you go to EKS, your control plane nodes are not running on their own AMIs, EC2 instances, they're running inside of containers, right? So it's virtualized, you just don't see it. With vClusters, you see it. And so that's the big difference. When we get to chapter 19, when we do when we get to chapter 19, we'll show a little bit more of how you can use GitOps inside of vClusters to make that a little bit easier. But yeah, no, ultimately the biggest anti-pattern I see with vClusters is people don't treat them as Kubernetes clusters. They treat them as something less, and they really shouldn't. Not if you're using them for production workloads. Great question, as always. So yeah, when we speak next, we're going to be diving into Open Policy Agent and Rego, everybody's favoriteest thing in the world. I will not hear ill things about Rego. Actually, I'll probably be saying a lot of ill things about Rego, but only because I love it. It's a great system. It does a great job. It's got some really interesting approaches that we're going to dive into in the labs. And we'll see you next week. Thanks for coming. And again, if you enjoyed the book, or even if you didn't really, but I'm supposed to say that. Scott gets mad at me if I don't. But really, if you enjoyed it, please, Amazon, we need reviews. We really, really need reviews. It makes a huge difference as to where we show up in the list when people start searching for Kubernetes books. It'd be greatly, greatly appreciated, especially if you bought it on Amazon. So anyway, have a great rest of your day, night, evening, morning, wherever you are. Thank you for joining, and we'll see you next week.